Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Geometry Common Core Regents problem number 31. If you want to access these exams anywhere in the world, go to nysedregents.com, click on the appropriate tabs. Here's the problem, and it's normal to read the problem a few times. Sorry, those were practice marks. In the diagram below, a window of a house is 15 feet above the ground. Okay, that looks like it's going to be a window. A ladder is placed against the house with its base at an angle of 75 degrees with the ground. Okay, determine and state the length of the ladder to the nearest tenth of a foot. Now, definitely pause the video. Try the problem on your own. Don't jip yourself and just keep playing, because you can do it. But if you just watch, you might you might convince yourself that you know it without actually knowing it, and vice versa. You might convince yourself that you don't know it when you actually do. So pause the video, try it on your own. It's normal to read the problem 4 times, even more if that's what is needed. So here's what we do. First, we make sure that we're answering the question that we're asked for. Determine and state the length of the ladder, okay, and then to the nearest tenth. So we're not going to mess that up and get like the nearest hundredth or nearest thousandth or some weird answer. The ladder, now with the ladder, how do I know that this side is the ladder? We're going to call it length x. How do I know that that length is x, is the length of the ladder? Because it says the ladder is placed against the house with its base angle of 75 degrees. So now I know that this is the side of this triangle that I need. Now, geometrically speaking, I could tell that the ladder is, as a check. First off, the ladder has to be longer than 15 feet, because the ladder can't reach up 15 feet if it doesn't measure 15 feet, right? Also, the hypotenuse of our right triangle is longer than all of its legs for that exact reason that I just described. Second, though, the ladder's not going to be much longer than 15 feet. How do I know that? Again, just visually speaking, it's not double the length. It's a very tiny amount bigger than 15 feet. So if I get an answer like 20, 25, 30 for the length of the ladder, I know I'm wrong. And you should check why you got that answer. So I need to get x. What sides are that side relative to angle 75 in terms of SOHCAHTOA? Remember SOHCAHTOA? In terms of that, which sides are those? So the 75 degree angle is here. I go straight to the opposite side, so that's opposite. So 15. So and then this side is the hypotenuse, because it's the long side of the right triangle. It's opposite the right angle, so that's the hypotenuse. So I might as well use sine. So sine of 75 is equal to opposite over hypotenuse. They don't want an exact answer for sine. We've made an extra practice problem, so keep that in mind. They don't want the exact answer for that number, but keep it in mind. Okay, so opposite is 15, and hypotenuse is x, and this is sine 75. I'm going to put this over 1 because I know a lot of the kids love cross multiplying when they're solving equations with a variable in the denominator. So x sine 75 is equal to 15, and I'm going to divide by sine of 75, and this confirms for me mentally, because I'm comfortable with sine of theta, that the answer is going to be close to 15, because I know sine 75 is close to sine 90. Sine 90 is 1, so this is close to 15 over 1. This is a confirmation that I'm going right. So x is equal to, then I turn on my calculator. Now, a lot of kids get this question wrong for this one reason. They forget to go to mode and change the mode to degree. So what happens if you change the mode, if you keep the mode in radian? Radians are just a different way of measuring angles, but they're a different way of measuring angles. So if you plug in 75 into the calculator and you're in radian mode, it's going to say, hey, 75 radians. Now, what are radians? It doesn't matter for us. The point is that they're different. They're not degrees. So if sine 75 and you're in radian mode, that's 75 radians, and that makes no sense for this problem. We need degrees. So 15 divided by sine 75, and we got 15.52. Okay, 15 0.529, and x is approximately, and they said to the nearest tenth, so 15 point, let's see, 5. The 2 means we keep the number the same, so 5. And do not put units. In physics class, put units. In chemistry, put units. In math, never put units. That's one of the failures of the curriculum, is they never require units. They should actually teach it to require the units, but they actually do the opposite. They almost force you to not use units, because if you use the units and you use them incorrectly, you lose points. So, but if you don't use them at all, they're almost always stated in such a way that you don't need the units. So the hypotenuse is like 15.5, as we expected, very, very close to 15, less than 16. So that's our answer. If all you wanted is the answer, you're done. That's it. You can go click the next button and you're done. But we did create an extra practice problem for you out of the kindness of our hearts, and it's crazy. So let's see if we can do it. In the diagram below, it's the same diagram of a window of a house is 15 feet above the ground. A ladder is placed against the house with its base at an angle of 75 degrees with the ground, and then determine and state the exact distance between the base of the ladder and the wall. In simplest radical form, you may use the following values without proof. Wow, sine 75 equals radical 6 plus radical 2 over 2, and cos 75 equals radical 6 minus radical 2 over 4. Sorry, not over 2, over 4. Okay, this is the length that they want. Let's see, the exact distance between the base of the ladder and the wall, x. If you give an approximate answer, they will give you some points. They won't give you full credit, but they will give you some points, as long as you made no other errors along the way. But we need an exact answer. So what does an exact answer mean? It means that it's correct to infinitely many decimal places. You know you can't write infinitely many decimal places. So how do you write an answer exactly? You leave the radicals. You don't plug the radicals into the calculator and get decimals. You don't do that. You keep the radicals. So we have, for the 75-degree angle, we have, again, we draw an arrow to the opposite side. This is opposite, and this is the hypotenuse, because it's the opposite of the right angle, and so this is the adjacent. Okay, so we have an opposite, which we know, and an adjacent side, which we're looking for. So we're going to use the tan function because of so, ka, toa. I'm sorry that I was waving away a fly. An inconvenient fact, we somehow got a fly problem for just a day, and I can't get rid of it. And I have to record videos. I have too many videos. So tan of 75 is equal to opposite over adjacent. Okay, now how do we do this? We have tan 75, let's see, is equal to sine 75 over cosine 75. Okay, and this is equal to opposite, which is 15, over adjacent, which is x. Okay, let's plug some numbers in. Sine 75, without proof, we are given that it's equal to radical 6 plus radical 2 over 4. And then cos 75 is radical 6 minus radical 2 over 4. Now at this point, you might be frightened into just deciding we have to stop. But I would actually advise you, even if you don't know where to go to the final answer from here, I would bet money that you know something that you could do that is correct. And frequently that one something leads you to one something else, and then something else, and something else, and suddenly the problem is done. I see, for example, on the right side, on the left side, we have two rational expressions, one on top of the other. Let's get rid of one of the denominator from each of those by multiplying by 4 in both the numerator and the denominator. So that 4 cancels this 4, that 4 cancels this 4, and we get radical 6 plus radical 2 over radical 6 minus radical 2 equals 15 over x. Now, what do I do here? I know the kids love cross multiplying. That is a very advisable method. I know a lot of my students, I teach them that they can take the reciprocal of both sides. If two fractions are equal, then their reciprocals are also equal. But it's a little bit too heady for students for some reason. Not sure why the first time I say it. So let's just leave it at that. We'll cross multiply. So x times radical 6 plus radical 2 equals 15 times radical 6 minus radical 2. And then we divide, x is being multiplied by this radical, so we would divide by this radical, plus radical 2, plus divided by radical 6 plus radical 2. And at this point, you would get a point if you just write this. So x equals 15 radical 6 minus radical 2 over rad 6 plus rad 2. You would get a point there, but they want simplest radical form. How do we get simplest radical form? All we need to do is get rid of those radicals in the denominator. And hopefully, if your teacher taught you what are called the conjugates, then you know to multiply the numerator and denominator by the conjugates. But the conjugate of the denominator. But if you don't know what that is, the conjugate of this denominator is the same expression, but instead of with a plus here in addition, it's with a subtraction. So radical 6 minus radical 2 and radical 6 minus radical 2. And what's the benefit of this? The benefit of this is that it rids us of the radicals. It's the one number that when we multiply the numerator and denominator by, the radicals in the denominator disappear. So 15 times radical 6 minus radical 2 times radical 6 minus radical 2. And then the denominator becomes, let's see, we should actually multiply this out. Let's erase a little bit. Sorry, I was about to rewrite the same thing I had just written. So I'm going to, on the side, here's my scrap. Okay, yes, this is a lot of work. It's an extra problem. It's meant to rack your brain a little bit. I'm going to do here, I'm going to multiply the numerator, I'm going to multiply the denominator separately. So let's see, radical 6 minus radical 2 times radical 6 minus radical 2. And we get radical 6 gets multiplied by each of these, and radical 2 gets multiplied by each of these. So radical 6 times radical 6 is 6, plus minus radical 6 times radical 2 is radical 12. And then minus radical 2 times radical 6 is 2 radical 12. And then minus a negative radical 2 times negative radical 2 is plus 2. Okay? And this simplifies as 6 minus 2. Radical 12 is radical 4, radical 3 plus 2. Okay? Which equals 6 minus 2 2 times 2 times rad 3 plus 2. And then 6 plus 2 is 8. So 8 and 2 times 2 is 4 minus 4 rad 3. Okay. Then I'm also going to multiply the denominators. So I got rad 6 plus rad 2 times rad 6 minus rad 2. And again, this is this rad 6 minus rad 2, this conjugate is the exact number we multiply by to rid ourselves of the radicals in the denominator. So rad 6 times rad 6, rad 6 times rad 2, rad 2 times rad 6, rad 2 times rad 2. So rad 6 times rad 6 is 6. And then rad 6 times rad 2 is rad 12, minus rad 12. And then rad 2 times rad 6 is plus rad 12. And then rad 2 times minus rad 2 is minus 2. So this is equal to 6, and that cancels, minus 2 is equal to 4. So the denominator is equal to 4. And the numerator is equal to 8 minus 4 rad 3. So 15 times 8 minus 4 rad 3. And then the denominator is equal to 4. And the 4 cancels this, it's a factor of the numerator. Let's see, 15 times 4 times, let's see, 2 minus rad 3 all over 4 equals, sorry, I hate doing this. I hate when students do this, but hey, what am I going to do? So here, x equals, so the 4's cancel, and that's as simple as it gets. X equals 15 times 2 minus rad 3. Okay, and this should be the, by the way, if we had to look at it intuitively speaking, we know that the bottom side, this diagram does look like it's drawn to scale. So the bottom side is definitely less than half, maybe a third or a fourth of 15. So we should get a third or a fourth of 15 if we plug that into the calculator as a check. And let's see what we get. So 15 parentheses 2 minus the square root of 3. We should get something again around a third or a fourth of 15, so 4. That's the answer. It's approximate. That's the approximate answer. This is the exact answer. This confirms that our answer at least is plausible and it makes sense. So this problem is done. This whole mess of a problem. Look, it was meant to be tough. I actually made a problem that was meant to be tough. That was my point. Hopefully you got something out of it. Hopefully you see this and you're like, okay, you know what? I got something out of it. Maybe I don't understand the whole thing. Maybe I can watch the video again and copy it down, and maybe when I copy it down, maybe it starts sinking in. That's what I highly recommend that you do. Listen, getting good at this stuff just takes a little extra work. The average student would just stop the video, go on to the next video. The really good student would go watch this video again, write these notes down, and try it and see if it really sinks in. And I bet you it will if you do that. You can do it. I believe in you. Just keep at it. Thanks for watching and stay tuned for the next video starting right now.